In the last lesson, we talked about factors that go into determining what the climate is. In the next couple of lessons, we're going to be talking about climate change and what things can happen to change the climate of an area. And we're starting, and I started with this slide with just a graph showing global temperature. The 5-year mean is the red line, and the annual mean is the other one. But basically, you can see that, yes, the climate is getting warmer. And I purposely picked a graph to start with that didn't have anything about carbon dioxide or methane or anything like that, which can be a little bit controversial still about the human impact of climate change. Basically, you can see in graphs like this that the temperature is warming. Okay, the climate is changing. There have been times in the past when the temperature has cooled. Okay, the climate has cooled, the ice age. So I started with the graph that didn't have, like I said, any carbon dioxide or methane, just to show you and talk about there is a climate change. Whether or not humans are a factor in it, we don't need to talk about that yet. We'll talk about that more in the next lesson. We're going to start with just talking about things that can change the climate. And we know that climate has changed. I put a picture of here. This is a spruce tree house and in Mesa Verde National Park. The Anasazi used to have their cities under the cliffs here. They had to move a long time, 500 years ago or so, because of climate change. This is a picture of Glacier National Park, which does not have many glaciers left anymore. Another example of climate change. So like I said, we're just going to run through factors that can change climate. We're not going to do any human ones in this lesson. We'll save that for the next lesson. So we're starting with the Milankovitch cycles. And these were figured out in the 1800s by a Serbian guy named Milutin Milankovic. And what he found were that there were changes in the Earth's rotation and revolution around the sun that can change the climate. And he found 3 different cycles. He found eccentricity, obliquity, and precession. Eccentricity is the shape of the Earth's orbit, so changes in the shape of the Earth's orbit, or the ovalness, so changes in the ovalness of the Earth's orbit. So we go from having kind of a more circular orbit to a more oval orbit back to the more circular orbit. And how long does it take to go through a cycle? It takes about every 100,000 years. Well, how can this affect climate? Hopefully you should be able to see that, well, if we're really oval and we were closer to the sun while we were oval at certain times, it would be hotter. Okay, it's going to change the climate. Obliquity, that's changes in the tilt of the Earth. So we go from being tilted somewhere around kind of like 21.5 degree tilt, let's put 21.5, to about a 24.5 degree tilt, so I'll angle it a little bit more, so it's about 24.5 degree tilt, and then back to kind of a 21.5 degree tilt. And how long does it take to go through that cycle? Well, about every 40,000 years or so. Well, how would the tilt of the Earth on its axis affect the climate of Earth? If we're tilted a lot, so like in this case, if we're tilted a lot, that would make our summers really hot because the intensity of the sunlight would be a lot stronger. The sun would be more overhead, so the directness of the sun or the angle of the sun hitting us would be a lot stronger. Okay, so that could lead to be a lot warmer summers. Okay, climate change. The last cycle, precession, is one that's maybe a little bit harder to understand. You can see in the pictures here, but basically what happens is, right now, let me try to draw this here. So here's the sun. So right now, we are tilted kind of like this, and we're pointing to Polaris, the North Star. So Polaris is up here, the North Star. Okay. We go from doing that to the Earth can wobble. Okay, so precession is the wobbling of the Earth on its axis, to pointing, oops, there's the sun, pointing to a different star, or just not to Polaris anymore. and then going to back to pointing to Polaris. Okay, so kind of the angle or which direction the Earth tilts in space also changes. And that cycle is about every 20,000 years. Now, how that one affects climate might be a little bit hard to understand. Let me jump to the next slide, and then I'll jump back to this. Um, so it's kind of about the which way we're facing and how close we are. So remember your terms aphelion and perihelion. Aphelion is when we're farthest away from the sun. Perihelion is when we're closest to the sun. So if we are tilted towards the sun when we're far from the sun, like in this case, summers are a little bit cooler, and then we're closest to the sun when we're tilted away, winter's a little bit warmer. So we're closer in the winter, farther in the summer. That's pretty nice. The opposite could be this. We could be tilted towards the sun when we're closest to the sun and make for really hot summers, or we could be tilted away from the sun when we're farthest from the sun, which could lead to cooler winters. So definitely can affect climate. So right now we're in this situation, which is nice. Okay, in the northern hemisphere, we're talking about northern hemisphere. Southern hemisphere, of course, is the opposite. In southern hemisphere, they're tilted towards the sun when they're closest, really hot summers, and then they're tilted away from the sun when they're farthest, a little bit cooler winters. Okay, so we have the ideal situation right now for us in the northern hemisphere. So those are three things, like I said, that can change to change the climate. Now, let's kind of think about them a little bit. Let's say we're sick of this global warming. Everybody's talking about global warming. Let's get a global cooling. Let's try to get an ice age. Let's kind of just go through and think about, well, where maybe could we be to get a global cooling? So let's look at our orbit shape. Circular to oval to mostly circular. And this is kind of nearly circle. The maximum it gets is about 4% oval. Okay. So where are we right now? Are we near the circle? Are we near the really oval? Where are we right now? Well, right now we're kind of in, I guess I would say like right in here maybe. We're at 1.2% eccentric right now, going towards more oval. Which would lead to a global cooling? Would it be more circular or more oval? Well, it'd be the more oval, because we could be farther away during the wintertime. That's what we're trying to do. If we want an ice age, we want summers to be colder. Winters are already cold, fine. We want summers to be cold if we want an ice age. Okay, if we wanted global warming, we'd want the opposite, right? We'd want winters to be warmer. But we're done with global warming, let's say we want ice age. So we'd want this 4%, okay, to get it cooler in the summer. Okay, let's look at the obliquity. We go from kind of 21.5, 21.8 to 24.5 to 21.5. Where are we right now? Well, we're at 23.5 about, going towards the 24.5. So we're kind of right in here. 23.5 degrees right now. Is this going towards cooling or going towards warming? Well, it kind of depends again on the last one. But the more tilted you are, the more direct the sunlight will be during the summertime. That's not good, right? So we'd want it to be kind of more the 21.5 if we wanted an ice age. The precession here, it's kind of hard to just pick one of these. We need to kind of think about what we saw in the last one. If we wanted to get an ice age, what we would want is we would want summer in northern hemisphere. So NH, summer in northern hemisphere at, would we want perihelion or aphelion? Okay. If we want it to get ice age, we want to be farther, So we'd want it at aphelion. So summer in northern hemisphere at aphelion. So we have summer when we're farthest away. So that would cool it down. So if we got all three things lined up, we could get global cooling and ice age. But of course, if we did the opposite, if we picked kind of the correct ones, got all three lining up correctly again, it could lead to global warming. If you get 2 out of the 3, we could have a little bit global warming, or 2 out of 3, a little bit global cooling, a little ice age. So again, the Malenka cycle is non-human caused things that can dramatically change our climate. And they will all three line up. You look at the numbers here, you could pick like greatest common factor and or least common multiple, I guess, and figure out how often all three of these would line up exactly right or maybe exactly wrong. So those are the Malenka cycles. Next one we run through really quickly, sunspots. As you know from the astronomy unit, the sun has spots. They are cooler areas on the surface of the sun caused by magnetic field. Look at this graph here, comparing sunspots to global temperature. Same thing here, northern hemisphere temperature to sunspots. What we find is there is a very strict correlation. The more sunspots there are, the warmer the temperature. The fewer sunspots, the lower the temperature. Again, not a human-caused thing at all, but sunspots do affect the climate of the Earth. Volcanic activity. Again, one that is not a human factor, but again, it does affect the climate of the Earth. So we have here, kind of look at the bottom first month. So the 0 month, that's the eruption of the volcano. So this is basically, think of it as 5 years before the eruption and then 5 years after the eruption. First one here is Krakatoa in 1883, before to after. On average, it's cooler after than before. Pele, before and after. You can see it's, kind of cooler after on average. Agun, before and after. And again, cooler after. El Chicon. Well, this one's not so close. Kind of about even. Down at the bottom, Pinatubo. Again, a little bit more cooler after. The composites, this is kind of all volcanoes put together. You can definitely see that it is cooler after volcanic eruption. So volcanoes can lead to climate change as well. Some people talk about them releasing carbon dioxide, which can be a greenhouse gas, but when they erupt, they can release lots of ash into the air and other aerosols into the air that can block the sun, which then means there's less radiation getting to the surface, so it's going to cool down the Earth. So volcanoes can lead to a global cooling. Plate tectonics. So you see it's kind of a picture Pangea and all the continents moving around. Well, how can they affect climate? Plate tectonics affect climate kind of in every way. If you think of those climate factors that we had learned in the last lesson, plate tectonics, they will affect the latitude of an area. They'll affect the altitude by making mountains. They'll affect the distance from a water body. They'll affect ocean currents. They'll affect the prevailing wind patterns. They'll affect the mountain ranges, monsoon. So all those climate factors that we talked about, plate tectonics can change them. So plate tectonics is a huge factor in climate change. It's a very, very, very long-term factor, millions of years factor, but it still is a factor for changing climate. Then the last one I want to talk about today is El Nino and how that can affect climate. And I'll go through it fairly quickly, so I'm not going to give you all the details and the history behind it. But I'll kind of, like I said, we'll go through the basics of what it is. So El Nino is a warming of the ocean water off the west coast of South America. So it's a warming of the ocean water off the west coast of South America. So you see in a picture like this is where we're talking about. This red is warmer, so we have this warming off the west coast of South America. In this picture up here, El Nino is the top picture, a warming of the water off the west coast of South America. And then same kind of thing in here. Well, why do they name it El Nino? the boy or the little boy, because it usually happened or used to happen kind of around Christmas time in December. So basically named after Jesus, okay, the boy or the little boy. Um, so it happened kind of usually around Christmas time. It was not kind of all that frequent thing. It happened every few years, 5 years, 7 years. It would happen. It's gotten more frequent and more intense. How does it happen? Basically, or let's start with where should the warm water be? If the warm water shouldn't be off the west coast of South America, well, then where should the warm water be? The warm water should be more near Australia. You can see kind of in this picture. Well, why would the warm water be near Australia? Because of the wind zone. Remember, near the equator here, those are the trade winds. The trade winds blow, or should blow, the warm water towards Australia. If the trade winds die down, then that warm water can go back towards South America. That kind of shows this in here a little bit. Strong trade winds should blow the warm water over here and make it cool by South America. If those trade winds die down, the warm water can work its way back and it makes El Nino. It makes it warmer near the coast there. So how does El Nino change the climate? And also La Nina, which we didn't mention La Nina, may I'll mention La Nina really quickly. La Nina basically the opposite. So instead of a warming, it's a cooling of the ocean water, you can see in this picture, because the trade winds intensify. So now, how does El Nino or La Nina affect the weather? Mainly it affects, kind of as you see in this picture, it affects where the pressure zones are. When it's hotter here, the air is going to rise, which makes low pressure. Low pressure makes clouds and rain, okay, bad weather. So you can see that where the warm water is going to affect the weather of an area. Well, if there's warm water normally here and cool here, there's going to be low pressure here and higher pressure here. Well, if we change that during El Nino and we get the warm water here instead, we're going to have lower pressure here than normal and higher pressure here than normal. And that's going to change the wind patterns. And you can see a little bit up in here kind of where it is, and if you think Texas-wise, in here, okay, and then Texas-wise, where are we in this one? Kind of hard to see here, that during El Nino, the subtropical jet is actually farther south of us. So we actually have cooler weather usually during El Nino for us in Texas. So El Nino is actually a good thing down here in Texas. Some other ones. So you see here again El Nino, and we see kind of we're in Texas here. Okay, summers are probably gonna be cooler. That subtropical jet might be above us or below us. Okay, we're in between here, getting cool weather. During La Nina though, look at where that subtropical jet is now. It's way north of us. That means Texas is in the really, really, really high heat. When we get this to happen, La Nina, that's when we have summers where we have over 100 days, or we have 50 days, 60-degree days, over 100 degrees in a row. Okay, La Nina is horrible for Dallas, or horrible for Texas, because it's changed these global wind patterns. We are now in the really hot section as compared to a regular year or an El Nino year when that subtropical jet is below us and we have a much cooler summer and we have more rain. Okay, the jet can bring rain. Now we're not going to get it. This one again showing a La Nina and why that's really bad or for us down here in Texas. That the subtropical jet is way too high. It's going to be up there bringing the moisture and the cooler weather up there while we are going to be dry and hot. Okay, so kind of simple thing, you're kind of finishing it off here. El Nino is a warming of the ocean water, and that can affect climate because it's going to change the global wind patterns. It's going to change where the high and low pressure areas are, change the jet streams, and change where we're getting this cooler, wetter weather or hotter, drier weather. Those are kind of a few of the non-man-made effects for climate. we are going to talk in the next lesson about some human impacts. We'll talk about global warming. Is there a human influence? So we're going to save that for next lesson.